Well, good morning, everybody. Welcome to Eric's Edge, and I hope you can hear me. If there's a viewer out there that can confirm, I would appreciate that. Um, anyway, so far we've got Dave's Vintage Apple Tech and One Bit Fever Dreams ready to science the out of this. Okay. Yeah, interesting thing. I live in a university town, and there's two colleges. One is Michigan State University. It was a land grant university that was founded back in the 19th century. Anyway, um, they do a lot of agricultural stuff, but they also have, the usual, they've got an astronomy program, yada, yada, yada. So the library there, I used to spend a lot of time there when I was going to university there, um, perusing the stacks, using card catalogs, because it was all paper-based card catalogs back then. Um, Looking at periodicals. I didn't have a lot of money to subscribe to magazines, so they had Dr. Dobbs Journal and other stuff, and so I spent a lot of time there. Um, and then there's another community college that's in Lansing called Lansing Community College that I also attended before I went to Michigan State University, and they had a small library, but it had some interesting stuff in it. They actually had a computer catalog as well as the card catalog at the time. So, um, yeah. Anyway, one of the things that the university library has is an extensive media collection. They have the obvious, music library for music students, that kind of thing. But they also have software as well as other media. And I don't know why it's been, ugh, let's see, how many years? 45 years, 40 years since I went to that library. Um, Changed a little bit since then. The second floor has a small maker space, which is kind of cool. And they consolidated all the separate university libraries a number of years ago. So they actually store a lot of their content in a warehouse out near the airport north of Lansing. And anyway, so I was perusing the catalog. I got a community library card so I could check things out. And they have a lot of HyperCard media um, in the media center, and you can check it out. And it's the original floppy disks or copies that were made. Um, yeah, so I started poking around and checking out some titles and came across this one. Let me change my screen here. There was a company that had a catalog of Macintosh software, and this is one of their catalogs. And it was a lot of media for educators and things like that. They'd have, in the catalog, tools and utilities, language arts, physical science, mathematics, all that kind of stuff. And yeah, so they sold software that educators could get and use, which is kind of cool. I don't think they exist any longer as a company. Wasn't able to find much except found this catalog. Anyway, there's also a Scientific and Graphical Toolkit was one of the things they had. Yeah, peak 90s. Putting Einstein everywhere. So one of the things I picked up was a Scientific and Graphical Toolkit that was developed by Robert Harding and Steve Lay and Hugo Moule? I'm not sure how to pronounce that. I thought we'd take a look at it. I need to reduce this a little bit. There we go. So the system requirements were pretty minimal for this. You had to have a minimum of 1 megabyte of RAM. Operating system had to be version 6.0.5 or later. It required a hard drive. And you had to have HyperCard 2.0. So what they did was they put together a toolkit that would do a lot of mathematical calculations and things like that using external commands and external functions, which speeds up the execution a lot of the algorithms that they had. And it included graph drawing. They say it was 10 times faster than HyperTalk scripts alone, which I would believe. You could produce graphs and curves. You could do perspective views of functions, yada, yada, yada. So that's kind of neat. And the manual goes into what it is, how you can use it, the principles of operations, and etc. So why use it? In most cases, the greatest amount of effort in writing software for others to use goes into writing the user interface. That is true. HyperCard makes it quick and easy to create an intuitive user interface and has become an established variant of the Macintosh style. So you guys may know there were style guidelines for the Macintosh computers. HyperCard did not follow them. It did in general sense, but there were differences. And it'd be interesting to find out what the rationale was behind that, or what discussions there were. I should see if there's anything about it, articles about it, or interviews. But yeah, enough about the style. There is a price to pay for these advantages, and that is a loss of processing speed. So excuse me. Believe it or not, I'm doing this without coffee, which is dangerous. I made coffee this morning and I used half and half with it, and my coffee sat here for a bit, and it had a skim across the top of it, and I don't know if that was because the mug wasn't absolutely clean, or if the half and half is starting to, I don't know what it was, but it was like, I'm not going to drink this. So I have to make coffee after we do this. I'm not used to doing that. I'm used to having at least some caffeine when I start, but yeah, we'll try. I don't know how long I'll survive. Anyway, so they're equating processing speed with a trade-off for user accessibility or ease of use. So HyperTalk was an interpreted language, and interpreted languages give you certain advantages. Immediate execution, you don't have to compile it. You can find out if it works right away as you're building it. You don't have to have a complete program to compile, things like that. So, but that comes at a sacrifice of speed being interpreted. So I think that's what they're getting at. HyperCard has therefore been an attractive system for authors of education software where processing speed is not critical, but where presentation and ease of control by the user are the utmost consideration. Okay, that's a fair trade-off. Anyway, they go on to, so what they did was they developed some tools that you could use with HyperCard to perform mathematics. Well, let's poke around at the actual stack now. Do they go into, so they go into how to use it. They have some examples of doing plots. They discuss the structure and how, you know, HyperCard uses external commands, things like that. X block types are assigned to different types to ensure that, for example, data intended to define a window cannot be interpreted as a solution of a differential. Okay, so they get into a lot of their how things are arranged, how they handle errors. They have something called an X control command. Anyway, okay, enough of the manual. This is available on the on Macintosh Garden. I did upload it there, so if you wanna take a look at that, you can. Excuse me while I switch screens. So I have here, and I have to switch mice. This is the Scientific Graphics stack. They actually, this is a copied floppy. They mislabeled the floppy and misspelled scientific. It said scientific copy. So anyway, so quite often when you got diskettes back then, you would make a copy of the diskette so that you didn't have to worry about it, you know, the original going bad. So I don't know if the original disk that came with the software still exists and only the copy that is part of the media library is there. I should ask them sometime. Another quick side conversation. The person that was running the library, the media center library, Friday. I stopped in there in the morning. His wife does media preservation at the university, at the library. And I was, you know, he ran off to the stacks to pick up this stuff for me, and he came back and got to talking to him a little bit and explained why I was, checking out this stuff. He says, I'm surprised we still have this, you know, etc. Got into a conversation about vintage computers. And he asked me if I'd be interested in helping his wife out with setting up machines that can use the media that they have. And I said, well, of course I would. So gave him a card that I made for VCF that's got some contact information on it. And so I'm looking forward to hearing from her to see if there's something that I can do to help him out, you know. It would be nice if they had a little vintage equipment lab that they could lend out or perhaps use in the library itself so that people could actually use the things while they're at the library. Some of the media that they have can only be used at the library, so there's limitations with, they have to provide equipment to be able to do that. Anyway, so I thought that was pretty cool. Hope to hear from them. So there is several stacks on this set, the diskette. The demonstration stack, toolkit resources, simple example, a reference stack, and then the README. So let's go through it. The README is just a simple single card stack that shows information about what the thing is. Quit that. Let's go to the demonstration stack. Okay, now in HyperCard, you can simplify things by just removing the menu. I don't care for that because it's too curated an experience for me, but it was a style. I'll eventually go in and modify these stacks so that you can poke around inside in them. But for now, I'm just going to use them as they were delivered. So this is titled the Scientific and Graphical Toolkit for HyperCard Demonstration Stack. And it's got mystery meat navigation, but if you know HyperCard, usually you just click. The Scientific and Graphical Toolkit. What does the toolkit do? Snapshots, tutorial scripts, working model scripts, getting in touch. So, and it was also produced by Cambridge and Kiel University's team of the Renaissance Project, sponsored by Apple Computers UK. So this was done in the UK. Getting in touch. You can request a copy of the latest release and documentation by writing to Cambridge. You have to enclose a formatted disk and tell them which version of HyperCard 2 you're running. I wonder if I can get someone in the UK to mail them a disk and see if they'll fill it out. Something tells me they won't. Okay, so what does the toolkit do? The scientific toolkit can perform a variety of mathematical functions and associated graph plotting operations very much more rapidly than HyperCard on its own. And the demonstration stack contains a number of working examples. Click here to see a full list. X control. Initialize to dispose of the toolkit. Okay, X compile. X array. So HyperTalk doesn't have arrays. It does have lists, and you can change the delimiter for the list. So it looks like they have a control that handles arrays. XGraph looks like you create a graph with it. Contours does a contours map. Draws a surface of revolution. Draws a surface for values supplied in an array. Bar chart, pie chart. Integrate. Integrate a function over an interval. Interesting. Oh, and you could do a discrete Fourier transform form. So let's go back. Go back again. Snapshots. You can define functions. The revolution thing. Contours. Pie charts. Solving ordinary differential equations. Now, this is actually pretty extensive. They have tutorial scripts. Initializing and disposing of the toolkit, creating and manipulating and dispose of window. So and they have examples. Go. Woo, there's a window. Okay, this is really extensive. Setting up your axes, array utilities. So you can scale, add, concat, and do a subrange. Using arrays to be, okay. Yeah, you know, usually you don't find this much documentation with a stack. So that's pretty cool. Sorry, let me see what's going on in the chat. Oh, we got some people here. More people. Let's see. Ron. Hey, Ron. I wear a lab coat anytime I make scientific copies. Yeah. You can you can do a coffee cup surface of revolution, and your body will ache for it even more. The worst CPU wafer I've ever seen. So, oh man, yeah. I'm probably not going to be on very long today. because the brain is not here. Okay, so let's look at some of these working script models. So let's do XPy. So here they've got some data that you can fiddle around with, and then you can write a script. Oh, okay, so it gives you a form where you can fill stuff out and then create the script from it. And then you can execute the script. That's pretty cool. Huh. Let's add some data. Oh, wrong keyboard. Sorry. Let's see how good at error detection it is too. We're going to put some crap in here, but first let's just put some stuff in. So let's do some negative values. And let's write the script. Then it added those values to the script and hit go. And it probably doesn't really work too well on negative values for a pie chart. Let's put some crap in here. It didn't error. Sorry. Let's see. M. Let's add M. Write script. Okay, it wrote it using that in there. Hit go. Okay, it probably just ignores the value. That's interesting. Okay, let's go back. Write the script. So this does a fast Fourier transform of an n-point sample. And you can select different plots. Reset. Oh, there we go. Go. Interesting. I guess. I don't know. I am not a mathematician. I actually majored in mathematics when I started college, but I switched to computer science. So if I want to try a differential equation, m times x. Now, I'll leave that for other people that want to play around with it. Yeah, I maximize the window for the computer and sacrifice part of my name. Worst clothesline ever. Yeah, it's pretty saggy. Anyway, so let's close that. So, it seems to be pretty fast at executing. So that's kind of cool. I don't know what I'm doing here. There's a tutorial built into it. What other stacks we got here? So let's so they do the typical HyperCard thing where it's like you go to the home stack and then you can say I want to quit HyperCard. Tool resources. This stack is not supposed to be run. It contains the toolkit resources. So one of the ways you can do HyperCard, you can have stacks that have your resources in it, and then you can have other stacks load that stack so that you have access to the resources. So it's an interesting way to do it. Simple example. Let's see what their simple example is. This is a very simple example of how to use the Scientific and Graphical Toolkit. Section 2.3 of the Toolkit Manual. Run, click either of the data buttons, then the plot button. Data 1, plot. That looks like... that must be a quadratic equation. Data 2, plot. That looks like the same thing. Okay. Well, actually, let's go back to that. Open stat. So they probably have they've got this set at a different user permissions level than being able to edit the stack. Reference stack. Principles of operation. Well, there's definitely a lot to go through here. Looks like they have basically the printed manual is also included as a stack, so that you don't have to have the manual. You can just go through the stack. That's pretty cool. Okay. How do I get out of it? Oh, there we go. Oh, there's the home button. Finally. Navigation's a little weird. Anyway, that's pretty much it for that. I could see how it'd be useful to be able to do stuff. You know, if you were doing a stack that required some mathematical calculations and stuff like that, so it could be useful. Seems to cover a spot between having a graphic calculator and paying a license for Mathematica. Yeah, you can see how it could be useful. I don't know what they charged for this in the original catalog, but it's interesting either way. So, well, that's pretty much all I have for this morning. Being caffeine deficient, I'm going to basically call it a stream, and I intend to. There was over 400 HyperCard titles at the library, books and as well as media, and I'm gonna kind of do a tour through it. Some of them have to come from storage for me to get them, and do these short little presentations on what I find. So I want to thank everybody for coming out today. I appreciate you all. And I'm going to run. So have a good one.